Good afternoon, guys. Uh, I'm going to take you all through the areas that you got in the 1P paper. So first of all, we will go through the topics that were included in the 1P paper, right? Okay, so starting from the first topic, forces and motion, we got this area, the average speed, that was the first question, that was in the first question. I sent this to you guys, so you have the document as well, right? And in this area, v squared equals u squared plus 2as can be in the 2p paper, right? So 1p paper, again, forces movement. There was a question on the forces and the effects of forces. That was second question. Second question, we had frictional forces and the effect of frictional force. That was there. And this practical investigation related to Hooke's law can be in the 2P paper, right? And momentum. Momentum is a definite area which will be in the 2P paper. So you will get a one question from the momentum in the 2P paper, right? It's a must, right? You'll definitely get one question from momentum. Moment. You'll get a question from the moment as well, right? So they are only included in the paper 2P. So they will be in paper 2. Power, electrical energy can be in 2P paper. I wouldn't say that it will be there, right? It can be in the paper, right? And then there was a question on Ohm's law. We got a series circuit in the question 3, right? So that was given in the paper 1, right? And then energy equals to charge into voltage was in the 1P paper. That was in the question 11. Right, electric charge. There will be a question from the electric charge, right? There must be a question from the electric charge. Tomorrow's paper, right? It could be an application as well. Right. Waves. There was a question on waves equation and the properties of waves in your 1P paper. That was question number 8. Right? And the Doppler effect was given in the paper 1 as well. That was again question number 8. Right. So they have given ultraviolet light, which is an electromagnetic wave, in the question number 11 in your 1P paper. They have not given a question related to light waves in the paper 1. So we can expect a question related to refraction of light or investigation, right? Finding the refractive index. Maybe there can be a question related to a critical angle as well, right? In the 2P paper. Sound waves and practical, oscilloscope, right? Finding the speed of sound in air. A question related to an oscilloscope. These are very much possible questions in the paper 2, right? It will come in the paper 2, right? A question around sound wave oscilloscope, especially, can be there in the paper 2, right? In my revision tunes, which I've shared, I've carefully selected some questions which can be in your paper. So you can actually, you have the mark schemes as well. You can do those questions and practice and refer to the mark scheme and practice to get familiar with the areas which we are expecting. Okay, right. Moving on with the energy transfers. There can be a question related to conduction, convection, radiation uh, in your 2P paper. There can be, right? Work done was in the question 6 of the paper 1. Kinetic energy was in the question 11, right? Now, when we were going through the topics, right, we saw question 11 in various places. Question 11 was the last question of the paper, of paper 1, and that question had few areas together in the same question, right? Electric energy was there in that question. Waves, electromagnetic waves was there in the question, as well as kinetic energy was also in the question, right? So that question had few areas together, right? But the other questions were pretty much focused onto mainly a one area, right? So they were not that difficult in that sense, right? Then work and power was in the question 6, right? So there's an experiment, and the experiment was actually in the textbook as well, right? It was the same thing that they have given, right? Then energy resources can be in your 2P paper. Energy resources can be in your 2P paper. Density, as well as pressure in liquids might be there, right? Pressure was there in the paper 1, right? That was the question 7. Okay, so you'll get a one question from this area for sure, right? So you'll get a one question from heat energy. Delta Q equals MC delta theta equation is a one equation. You will have to use in tomorrow's paper, right? Be familiar with the heat energy, right? Specific heat capacity, right? I'm expecting this practical in the paper. I'll talk about the practicals which we can predict, right? Boyle's law was given in the paper 1, right? That was the question 7. So that was checked, but still, you might get a question on pressure and temperature, right? There is a possibility, right? Magnetism and electromagnetism, right? Practical investigation on how to find the magnetic field around the magnet can be given, but that's not very difficult if it is given anyway, right? So I don't think we have to worry about it much, right? But this is one of the important areas I would like to highlight, which will be in tomorrow's paper, right? Know that there is a force on a charged particle when it moves in a magnetic field, as long as its motion is not parallel to the field, right? If a charged particle is moving inside a magnetic field while cutting the magnetic field, a magnetic force can be exerted on the charged particle, right? They have given a question on electrical motor. That was the question 5, right? To explain how motor works, right? So they're not going to repeat that question anyway, right? So there is a possibility that you will get a question from the moving charge particle in a magnetic field or an electromagnetic induction, right? So electromagnetic induction, movement of moving charge particle in a magnetic field are possible questions in the paper tomorrow. And in your paper, there was one graph question, question number 10. That question was on magnetic forces, right? and they have given a question on motor and magnetic forces on current carrying conductors. So therefore, it's highly unlikely it's going to come again in your tomorrow's paper. So right. So therefore, there is a possibility that you will get a question from electromagnetic induction, that is generator effect, and a question from or a question from a particle, charge particle moving in a magnetic field. Right. I was trying to focus on some questions we got in the recent papers, right, in our papers as well, right, around moving particles, right? So they are in the revision tuned. Right, the other area related to electromagnetic induction, right, electromagnetic induction or transformers can be in your paper, right? So transformer question can be a calculation as well as it can be a qualitative question where they will ask about how the transformers will work, right? So you have much more focus on like tomorrow's topics actually compared to the paper one, right? And for everybody, most of y'all, tomorrow the paper is the last paper anyways, right? So you can focus much more on that paper and these topics as well, and you have a clear target as well as I mean you can expect certain questions in the paper, right? Certain questions must be there in the paper. When we check most recent papers, you can also check. Even I discussed with you all in the classes, out of like 8 to 9 questions in your paper, majority of the questions are from physics only content. Physics only content are these bold content, which the letter P, right, after the specification point, right? So those questions are definitely there in your paper, tomorrow's paper, because that is the only paper they have to check the knowledge of those areas, right? So they must check those areas. At least 70 to 80% of those areas must be checked, right? So there is a big advantage if you practice those areas, focus on those areas, because like almost all the areas will be, those areas will be checked in tomorrow's paper, right? Additionally, we figured out some areas which have not come in the paper one, right? There is a possibility that you might get questions from those areas, right? Okay, so we will do a little summary after going through the whole, we are in the 6th topic, right? After going through the whole syllabus, we'll again do a summary, right? So anyway, this document is shared with you all also, right? So you can refer to it, right? Okay, so when it comes to radioactivity, they have given half-life as well as count or the activity, right? They have given a question on activity, Geiger-Müller tube and measuring the activity, as well as a question on half-life as well, right? So you will not get these areas in the paper 2, and you might get some questions from and also they have checked fission as well, right? So there is a chance for you to get questions from fusion or questions from nuclear reactions, right? Nuclear reactions. No, that's a possibility, right? And also they have given you the nuclear reactor, right? Nuclear reactor was also given. So it won't come again, right? So now you are clear that you need to focus more on the nuclear reactions, right? Equations, and also alpha, beta, gamma radiation, their properties and uses and hazards of them, right? They are possible type of questions, right? Uses of nuclear radiation, uses and hazards of nuclear radiation could be there, because that practical on nuclear radiation also was given in the paper 1, right? In astrophysics, they have given a question on orbits, gravitational forces, planets, right? In the paper 1, right? And also stellar evolution. There was a small question on stellar evolution, but somehow it was checked, right? I don't think they are going to recheck the stellar evolution again, right? Instead, you have definitely other areas to be checked, right? So cosmology, HR diagram. So HR diagram could be in your paper, right? There is a possibility that you will get HR diagram or cosmology tomorrow. Cosmology as in uh, redshift and this equation, right? And even the previous tute I shared with you, right? I included some questions related to redshift as well. And the Big Bang theory, right? And the two evidences for the Big Bang theory, right? Redshift and the CMBR, cosmic microwave background radiation, and how they are being used, right? So there was a question in the previous paper, 1 or 2 questions in the previous papers, right? Okay, so those are the areas you can expect, right? Right, now let's see what are the experiments we can expect in our paper, right? The experiment can be a totally new one as well, right? Could be a totally new one, right? Meantime, we can predict few experiments as well. Hooke's law, right? Something related to material. It's a very basic type of experiment. And moments, right? Hooke's law, moments. Now, these two can be in the paper, right? You can check questions related to Hooke's law and the moments. And then the other one I would like to highlight is the refractive index experiment, right? Can be there, right? So Hooke's law, Hooke's law, refractive index, moments, and my highest preference is for this experiment, right? Finding the speed of sound, right? A sound experiment related together with oscilloscope, right? So that's like the favorite, right? There are 2 favorite experiments from my side in tomorrow's paper, right? I know how far it is going to be right, right? But what I feel is either you'll get this sound related experiment with the oscilloscope or uh, heat energy, right? Heat practical to investigate specific heat capacity of a material, right? So these could be a lengthy writing questions if you are given these experiments, right? Those are lengthy writing experiments, right? So one of them can be predicted, right? Specific heat capacity, or what is the other one? The other experiment is sound, all right? Sound. So these two, right? I would like to predict these two. So additionally, right, for safer side, uh, we can look into few more experiments as well, right? Whether they come or not, it doesn't matter because we need to try our maximum to kind of cover the areas which we can expect, right? Whether they come or not, it is all right as long as we try our best to somehow score maximum, all right? So the other areas are uh, Hooke's law, experiment like using a spring or could be a rubber band, right? Rubber or a wire, right? And then the next would be moments related experiment, right? And then the other one is refractive index, critical angle related one, right? Additional to these 2 experiments. There can be a possibility of density experiment, but density experiments are also being checked over and over and over and over, right? There is a possibility. But if they come, I hope those experiments can be handled very easily, right? But the two experiments which we really need to focus on, I would say, specific heat capacity and the sound experiment with the oscilloscope, right? Because these two experiments, or the questions rather, they are not seen in 1P papers, right? Since they are not seen in 1P papers, we are not much familiar with them, right? Because we were focusing on 1P paper a lot before we do the 1P paper, and then we had other papers to do from the other subjects. So our focus was mainly on, like, those papers, right? Now we are trying to focus hard on the 2P paper, right? So I think you need to focus more on those two practicals, specific heat capacity and the sound practical with oscilloscope, right? Sound practical can be given without an oscilloscope as well. Then it will be easy to write, right? But if it is given with oscilloscope, mic and those setup, I have given lots of revision questions on those areas, right? I'm doing this class bit early today as well, so that you have time today even to practice them, right? If it is done late in the evening, then you might not have enough time, right? If it was possible, I could have done it in the morning, but with the commitments of the students as well as even mine, I was not able to do it in the morning. So I decided to do it as soon as possible, afternoon, so that you guys have time, right? So these are the expected area. So they were marked in this document, which I have shared with you guys in the group, so that you can leisurely go through it while you're studying, and you can use this as a kind of a document where you do a ticking activity. Okay, I have covered this, right? So go through each of the specification point to see whether you know them, right? If you have forgotten them, please study, right? Because more theory you know, you will be more confident, right? You need to remember the theory, right? Equation list is given to you. Equations are given, right? Only thing is you should know, right, how to use those equations, right? Familiar with the equations, how to use them. Other than that, the equations are given, right? Whether you have forgotten the equation or not, doesn't matter. You have the formula sheet, right? But the theory, you need to remember, right? Theory needs to be studied over and over and over and over, right? So go through the bold content, physics only content, where you have this P sign, right, after the specification point, to see whether I can't go through each and every one right now because it'll be time taking, right? And some of you all have already, done this so many times studying, so that there's no point, it's a waste of time, right? But I'm emphasizing the fact that you must go through each of these points and do a ticking activity to ensure that you know them, right? And in the 1P paper also, you did not get 100% of the content, right? So in tomorrow's paper also, you will not get the 100% of the content that you study. That's the usual case, right? But for safer side, we can't take a risk thinking, okay, this might not come, so I don't need to study this, right? No, don't do that. But this bold content must be studied thoroughly, right? Because they are coming in your paper, right? 80% of them would be in the paper, right? 80% or more would be in the paper, right? So you must study them point by point. Okay, that's a one thing. And also, I have predicted some of the content which can come in the paper too. Like for an example, a critical angle question, right? So those areas can be in tomorrow's paper. So you have to study them as well, right? Rest, whatever came in the paper one, uh, you know, you had already done them and you had the practice and you had done a lot of paper ones before the paper one, and after that you did paper twos, right? So you have a practice, you have already practiced lots of papers and questions, right? So don't have any doubts on your experience, what you got, right? So the thing is that you need to ensure that you remember theory, right? You remember theory and you have enough practice to uh, handle the applications, right? Okay, so now I'm going to select some questions from uh, the the document I've shared with you last, right? Which I shared you all with you all today, right? Uh, so we will get into the question number 9, right? This question number 9 is on momentum, right? A Newton cradle consists of a set of identical solid metal balls hanging by threads from a frame so that they are in contact with each other, right? So this is one of the equipment we use to demonstrate momentum and Newton laws, right? Uh, a student initially pulls the ball A and to a side as shown. The student releases the ball A and it collides with ball B. States the equation linking momentum, mass, and velocity. So momentum is equal to mass times velocity. So whenever they ask you to write an equation, you should write the same wording as they mention, right? Do not write your own version, right? So you will write momentum equals to mass into velocity, or momentum is equal to mass times or m into v. Okay, each ball has a mass of 100 grams. At the time of collision, the ball A has a velocity of 3 meters per second. Calculate the momentum of the ball A at the time of impact and give the units. They have given you uh, mass in grams and velocity in meters per second, right? What you should do is, in this case, even though it's very open to write the units, right? You better convert the mass into kilograms because kilogram is the SI unit, right? So the momentum is equal to mass times velocity. So convert grams into kilograms. To convert kilograms into grams into kilograms, you divide it by 1000, that into velocity 3. So we get 0.3 kilograms meters per second. So ensure that you write your answer in the blanks given, right? Sometimes you have working here and there. And if you don't write the answer on the blanks, maybe examiners sometimes might not be able to identify which one is the answer, right? Whenever blanks are given, you write the answer on the blanks. After the collision, the ball A stops. Ball E moves away. The other balls remain still, right? So initially, the ball A was moving and the ball A collides on ball B. And after A collides on B, ball E moves out, ball A stops, right? So this is the scenario after. Now A is A has been stopped, right? So the E has been moved, right? The momentum of the ball E as it moves away is the same as the momentum of the ball A at the time of the impact, right? Now, this is pretty much important, right? Momentum of ball E as it moves away is same as the momentum of ball A at the time of impact, right? So ball A had a momentum before it collides on B, and the E gains a momentum for it to move out, right? So the momentum gained by E is same as the momentum A had, right? So what does that mean? A has given its momentum to E fully, right? A has given its total momentum to E. And that's why A stops, right? A has totally given its momentum to E, right? Give the reason for this, right? Why the whole momentum is given to E, right? Okay, now I'm coming back to this part. Newton cradle consists of set of identical solid balls. They are identical, right? Means their masses are same. So they have the same mass, right? They have same mass. They are identical. So when two identical balls collide on each other, right? If one is stationary, the one which is moving would give the whole momentum to the one which was stationary, right? Here B, C, D are trapped. They cannot move. So that's why they are not moving. But A gives the momentum to B, right? Understand? A gives the momentum to B, B gives the momentum to C, C gives the momentum to D, and D finally gives the momentum to E, right? E is free to move, so E will move, right? As A stops, the whole momentum has to be given to E from A. So therefore, right, E moves with the same velocity A had, right? So this whole scenario is just, if you roughly think about it on the surface even, right? That is to conserve the momentum, because momentum has to be conserved if there are no any external forces acting on the system, right? So only A and B are colliding on each other initially, and then BC, and then CD and DE, right? So whole collision is only between A, B, C, D, E, right? Only within them, right? So therefore, momentum is conserved since there are no any external forces. Momentum is conserved. Right? The student releases balls A and B together as shown below, right? Now, what do we expect, right? Here we just have to use the common sense, right? Predict what will happen to the other balls after the collision and give a reason for your answer, right? When one ball hits, one ball moves out, right? When two ball hits, two balls will move out, right? So what are the two balls at the other end? D and E. So D and E will move out together because A and B, two balls are carrying a higher momentum, which can be given to two balls, right? And A and B are going to stop. D and E will move together, right? This is also again because of the momentum is conserved, right? Since momentum has to be conserved, balls D and E will rise up. Right, so we will move to the question number 10 now. The diagram shows the fuel used in some nuclear reactors. The fuel is contained inside spheres. The silicon carbide layer of each sphere is designed to contain fission products for at least 1 million years. Right? Give the name of the fuel that would be used. Right? So what is the fuel? What is the fuel we usually use in the reactors? Uranium. Plutonium is also being used, right? Explain what is meant by the fission products, right? So they are the products or the particles which are formed after fission, right? So they are particles which are produced after fission. Right. Now you need to look at the number of marks given for this answer, right? So they have given you 2 marks. Means 1 point is not enough. And also they have said explain, right? So if it is an explaining question, you need to like reason it out, write more, right? So what should you write additionally? Right. So the examiner is expecting you to write some of the products, right? Name them, right? What are the products? Daughter nuclei, and neutrons are the products. Right? So we need to grab 2 marks here, right? So to grab 2 marks, you need to go into more detail in your answer, right? At least you need to write 2 points. If you write 3, 4 points, right? As long as you have time and you can manage your time, it's okay, right? You need to look at the action word here, right? Command word, explain. In the previous question as well as second question, they have said explain why it is important to contain these fission products for such a long time. Right? Why should we need to contain them? As in, you cannot just release them, right? You have to protect them, contain them. Why should you contain them? Simply because they are radioactive, right? So even the daughter nuclei are radioactive, right? Since they are radioactive, they produce ionizing radiation. You may say products are radioactive, right? Or they are unstable, right? So they produce ionizing radiation. Right? They produce ionizing radiation. And you write a bit further as well, right? And ionizing radiation is harmful for people. Right. Actually, I'm discussing these questions to show you what you need to write in an answer, right? Uh, Even though we have done so many questions and past papers, like still always we tend to not to follow the instructions of the examiner when you're writing the answers, right? When examiner says explain, we do not really explain, we go on to describe, right? And we don't look at the number of marks given for some of the questions, right? If it is an explaining question, I think it's pretty much easier because we know that you can go in depth with more and more points so that you can grab more and more marks, right? So as long as that's where you need to be thorough with the theory, right? So that you can write bit more and more by going in depth, right? To get more marks. But it doesn't mean that you can write anything you know. You have to understand the keywords you need to include in the answer, right? So the answers are can be very short, right? You don't have to write lengthy sentences. The examiner does not expect that. What examiner expect from you is that you need to show you have the understanding of the key theory, key points, key areas related to the particular topic, right? So the products are radioactive. That's key. They are radioactive. So therefore, they are ionizing radiation. They ionize. So ionizing is dangerous, right? Ionizing radiation is harmful for people. And if you want to say how it is harmful, they cause cancer, right? Cell mutation and all that, you can go to that level. Harmful for people, so the cancer can be caused. Cell mutation can be caused, right? So perfect. So you are done with that. So you have written about 3 4 points in a very concise manner. Okay, so your answer needs to have lots of jargon, lots of keywords, right? Technical terms related to the particular area, right? So that way you will stand much more greater chance to get full marks. What is the function of the moderator in the nuclear reactor? Right? Moderator is someone who is in the middle, who's like ensuring that the process is going on well, right? So the moderator makes the neutrons to slow down so that neutrons can be easily absorbed by the fuel rods. Right? So moderator slows down neutrons, right? Why neutrons needs to be slowed down? Because they need to be absorbed by uranium, so that uranium becomes more unstable by absorbing an extra neutron, so that there is a high chance for it to undergo fission faster, right? So it becomes more unstable by absorbing a neutron, right? So you know that uranium-235 absorbs a neutron and become uranium-236, which is more unstable than uranium-235. So it undergoes fission because of its unstable, because it is unstable, right? The nuclear reactor also contains boron control rods. Explain why. Control rods are used to absorb neutrons, right? As the name suggests us, control. It controls the chain reaction, right? As we know, in the fission process, extra neutrons are produced. So these neutrons are absorbed by uranium so that the process will be kind of multiplied by absorbing more and more neutrons, right? Because in the fission process, more than one neutron is released, sometimes 2 or 3 maybe, right? So each neutron will trigger fission. So that fission will produce more neutrons, and the process multiplies, right? If 3 neutrons are produced, each neutron will trigger 1 fission and produce 3 more, and each of them will produce 3 more neutrons. So 3 into 3 will be 9, and then 9 into 3, 27 and 81, and it goes on and on and on, right? So the fourth process will multiply it, right? So to stop that process, we need to absorb, or rather control the process, we need to absorb these extra neutrons, right? Control rods are absorbing these additional neutrons, which are fissile products. Right. B, the reactor cooled with helium gas. The gas enters the reactor at 500 degrees Celsius. What is the temperature in Kelvin? We have to add 273 to convert Celsius to Kelvin, right? In some of the equations, right, you know that you are restricted to use Kelvin only, right? So those gas equations where there is temperature, in all gas equations, we must use Kelvin. Uh, we tend to forget this fact, right? That's why I'm reminding this. That's one of the reasons I actually chose this also, right? Even the first part actually was in the one paper. It might not come, but actually I was discussing that to give you give you a guidance to how to write answers, right? And then the second part is to remind you that when you are using these equations, uh, gas equations, you have to convert Celsius to Kelvin. Uh, as well as just to remind you that gas equations can come, right? So 500 to plus 273, 773, right? Helium gas enters the reactor at the pressure of 8.40 megapascal and leaves the reactor at a temperature of 1170 Kelvin. Calculate the pressure of the helium gas as it leaves the reactor. Okay, so here we are going to use the equation which links pressure and the temperature, because the whole thing is on pressure, because the volume of the reactor would be same, it does not change, right? So volume is constant and pressure and temperature are changing. We know pressure is directly proportional to the temperature, right? When the temperature increases, pressure increases. When the temperature decreases, pressure decreases, right? Uh, so P1 over T1 is equal to P2 over T2, right? So these T1, T2 must be in Kelvin temperature, must be in Kelvin temperature. Otherwise, they don't, they are not directly proportional to the pressure. So P1 is 8.40 megapascal. The temperature, the temperature is 773 Kelvin, right? The new pressure needs to be found at the temperature 1170 Kelvin. New temperature is 1170 Kelvin, right? So we are substituting values in terms of megapascals. So you'll get the final answer also in megapascal. It is 12.7, right? You can keep the final answer in three significant figures, one decimal place. Right. Next one. Since this was not in the paper one, and I just want to remind you guys, like, you know, that there is this area which can be in the paper tomorrow, right? It's not like 100% sure, right? But can be, right? In case if it comes, right? Better to at least, kind of refresh on this. So that's why I included this. Student uses rectangular glass block to determine the refractive index of glass. The diagram shows ray of light in air as it enters the glass block P. The normal at P is drawn with the dotted line. So when you are drawing the normal, usually draw it as a dotted line. Otherwise, you'll be mixing up with the light rays. And light rays, always when you are drawing them, you need to ensure that you draw arrows, right? We often forget to draw arrows, right? Complete the diagram by drawing a ray that continues inside the glass block, labeling the angle of incidence I and the angle of refraction R, drawing the ray that leaves the glass block as well, right? Uh, so you know glass block is more dense, then the ray should